Hey guys, for today's build we will be using a joystick to control two servos via Arduino. So for this build we will need an Arduino, we will need a breadboard, we're going to need two servos, we will need a joystick and some optional screws for the servos. Then we'll need a butt ton of male-to-male jumper cables. They look like this, two pointy ends. And then we will need a few, I'm going to use 4 or so, if I can find them over here in my pile of things. I'm going to use 4 or so of these, which are male to female jumper cables. You can see that one end has pins and the other end does not. We're going to start by wiring up our servos. So if you look at your servo, on one end it has female pins and that goes straight into the servo. Let's see if we can fit a screw in there. I don't have my screwdriver with me, so it may not, it's not going to happen. It's okay. These levers that will come in Arduino kits and Pi kits, they just kind of snap on there, so unless you're really running them ragged, then they shouldn't come off. Alright, so what I'm going to start by doing is taking the female end. I'm going to use some male-to-male jumper cables and I'm going to plug them such that it can be plugged into the Arduino and back. My convention is for the ground cable, which is right here, the brown one, I use a dark colored jumper cable. And then for the live wire, if you will, or the orange one, let's see if we can get some better light. Maybe. For the orange one, I use usually either the same color or a red, just to let me know that, hey, that is the live wire. Okay, got a little ladybug, wants to go over my desk. So that's the live wire. And then for the signal wire, which is our third wire, in this case, I believe it is an off orange yellow color. I like to use either a white wire or a weird color like green. So we're just gonna plug that in right there. So now we have a very long servo, but we have 3 places where we can plug in wires. All right, I'm gonna go ahead and do that for, let's get it in frame. This is my first time with this new setup, so it's kind of exciting. So let's go ahead and wire up the other servo. Okay, so now we're going to bring out the Arduino, and this one is an Elegoo Arduino. It comes with most Arduino starter kits. You may get some that are a little off-brand, like the Hero Inventor board that you see a lot of ads for. It's a modification of the Arduino, so it's not technically a full-blooded Arduino, although Arduino itself is an open source hardware. So we're just going to set this right here. And we're going to bring in our breadboard. I'm a big fan of using breadboards. Some people have said, hey, you don't need a breadboard for that. I prefer the breadboard because it gives me enough space to work and do what I need to do. So if you don't want to use a breadboard, that's just fine. If you do want to use a breadboard, that's just fine. So we're going to take 2 male-to-male jumper cables. I'm going to use a black one. And these are really neat. If you haven't done Arduino before, you get your jumper cables in these little packets. And they remind me so much of the Red Vines candy. You can just peel them apart. So I'm going to use a black male-to-male jumper cable. You can tell it's male-to-male because it has 2 points on each side. Well, 1 point on each side with a total of 2 points. There we go. And then I'm going to strip this down to get the red jumper cable. So here we have a red male-to-male. It looks kind of orangish on the screen. I think that's just my lighting, but it's whatever. So I'm going to start by making my power jump from here to here. So I'm going to connect. Let's see if we can get a nice little close-up. I think that's as good as it's going to get. So I'm going to connect this to the ground right here. Okay. Then I'm going to connect my red to the 5-volt. There we go, just like that. Now generally you don't want to connect your power or power until everything's all wired up and you know that there's no shorts or anything, but it's okay for now. So I'm going to take my red wire. I'm gonna plug it into the positive side of my breadboard. So along the sides right here, let's see if I have a pointer. So along the sides right here, this line is a positive rail. You can see where the red is. That's the positive. Now you could make it your ground. It would just be kind of confusing. So whenever we use this, let's see if I can get this low. Whenever we use this, this entire rail, this entire positive rail becomes positively charged. And whenever we plug in our ground, this entire ground rail becomes our ground. So we're going to do that. We're going to take our ground wire and we're just going to plug it into the same row as our ground. So that it looks like that. So we now have a circuit going from our Arduino to our breadboard. And we can use these power rails. We can use these power rails to jump conductivity from here to here. Okay. So now we need to hook up our joystick. I'm gonna get this out of the way for a second. So our joystick has buttons just like well, not necessarily buttons, but functions just like an Xbox or a PlayStation joystick has. So it does this. And then it also has a clicky button. We will be using the axes today. We will not be using the clicky button. I'm trying to get my lighting a little better. I don't think it's working. The first pin is our ground wire. Second pin is our power button. The third pin, that's going to control our X. The fourth pin is going to control our Y. And the fifth pin is our button. We will be using the first 4 pins today. So let's see if we can get this bad boy back on there. Well, it wanted to come off, but it doesn't want to go back on. There we go. All right, now we have it back on. Cool beans. So you may notice that these are pins, and while we could wire them directly into the Arduino, I kind of want a little bit of mobility, so we're going to use the male to female pins. I'm going to get about 4 male to female pins. And remember, they have pins on one end, or jumper cables, not pins. They have pins on one end, and then they have pin receivers on the other end. We're going to use the pin receivers first. So they may come twisted like this. I'm going to make it such that, do you see the little metal bit right there? I'm going to make it so that all of them face the same way. So whenever I look at it from the side, I shouldn't see any metal bits showing on the side faces, but just on the front face, like that. There we go. All right, so I'm going to just slide these on here, hopefully all at the same time. Like this. Maybe. All right, let's see if I can get it. Are you ready, boys? Ooh, there it is. Yes, sir. All right. Now we just do a little bit of aesthetic untwisting. And there we go. Cool. Now we're ready to plug into both the breadboard and the Arduino. So this is where things can get a little hairy if you're not too good with organization. We're going to take our ends and we're going to split them a little bit down the middle, because one side is going to go to power and the other side is going to go to analog, because it's an analog stick. So we're going to find our ground wire, which happens to be the purple wire. I don't know if you can see that very well. Our purple wire is the ground wire. So we're going to plug that, oh, let's put it right here. We're going to plug that into the ground of our breadboard. So I'm going to plug it in down here. Okay, so our ground wire is now plugged into the ground of our breadboard, and then we're going to plug the positive end into the positive rail of our breadboard such that it looks like that. There we go. So we have negative to our negative, positive to our positive. And then for the other two, I believe, let's see, I believe that our X is going to go to A0. I don't know if you can see A0 right there. Here, but we can see it like this. I know that. There we go. This one's going to go to our A0. This is our X controller. And this one's going to go to our A1. This is our Y controller. Get in there. There we go. So that is the joystick wired. We didn't wire a wire for the SW or the button because we're just not using it, so there's no point. Okay. So like I said, this is the part where things can get a little hairy. We have cross cables. But that's okay. It comes out kind of nice in the end. There we go. So now we're going to take our servos. I'm going to start with the first one. I'm just going to call this Servo A. And I have it wired such that my purple wire is my ground wire. My red wire is my live wire. And then my green wire is my signal wire. On your Arduino, you will see that there is a side called... Let's see if we can get it in frame. All right. This side, you see analog in right here. And then this side, you can see right there, it says digital. So we're going to plug our servos into the digital side for the signal wires. We're going to take our servo and we're going to plug the ground into the ground. We're going to plug our positive into the positive. And then our signal wire, we'll bring that up. And let's see if we can get a little bit organized here. Our signal wire, I'm going to plug into... Let's see if we can weave through these little things. I'm going to plug this into digital 2. There we go. You can see how that is on digital 2 right there. And then it's really simple. For the second servo, we're going to do the same thing. Okay. So this one, I'm going to maneuver a little bit. Let's see if we can just split the wires here. There we go. For this one, I'm going to plug this into digital 3. So that looks like that. We have two servos. We have our joystick, but it's not doing anything yet because we haven't coded it to do anything yet. So let's do that.
To code this, we're going to use the Arduino IDE. So we're going to get started just by Googling it. Arduino IDE download. All right, so once that link pops up, it should say Software Arduino. Go ahead and click on it. And it will take you to the downloads page where you can download whatever version you have over here on the right. For example, I'm using a Mac, so I'm going to download this one. If you're using Windows, download this. If you're using Linux, download this. So I'm going to click on this. I'm going to bypass all that. And once it's finished downloading, I'll go ahead and install it. And open the Arduino IDE, and we should be met with this screen. Up top, you have a check mark. This is to verify that your code is okay. Then we have our upload. That will also verify the code, but it will take a bit longer because it also accounts for the time to upload to the board. Debug, I don't have a board plugged in, so no debugging. But whenever you do have a board plugged in, you can just connect it right here. So inside the IDE, you have two functions. One is the setup and one is the loop. And as you can see, as the comments say, we'll increase our font size a little bit. As you can see, as the comments say, The setup is for our setup code here. This runs only one time. This is where we declare things like pin numbers and pin modes, and we begin our serial communication. Inside the loop, this is where we create our code or write our code that is going to run on a loop. So this is the setup code. This is the functional code. But before we get to any of this, let's go ahead and go to the top of line 1 and press enter a few times. Up here, we're going to create the pre-setup code. Before we even do that, though, let's go over here to our library. It should be the third thing down on your panel. Go ahead and click it. And we're going to look for Servo. Now, a library is a bit of code written by somebody else that we import into our project to use. That way we don't have to write the code ourselves because programmers are lazy and we're all just a bunch of thieves. So once we find Servo, I like to use the ones that are made by Arduino or Adafruit because I know they're probably most likely legit. Once we find Servo, we're going to install it. And it will tell me down here in the terminal that I have successfully installed Servo. Okay, clear the terminal. All right, now that we have it installed, let's go ahead and use it. So we're going to do hashtag include. This is the common method of importing libraries into C++ files. So we're going to do hashtag include less than servo.h greater than. So what we've done now is we have 1, installed the Servo library, and 2, we have imported the Servo library now into our file. So the next thing to do is to use the Servo library in order to create Servo objects. These objects are things that we will manipulate with our code, and they will directly translate into the motions of the actual servos. We're going to say servo, that is our keyword. We're saying, hey, servo, make a servo. So servo, I'm going to call the first servo servo A, and you end it with a semicolon. So we'll say in a comment that this creates a servo object using the Servo library. There we go. Oop, wrong button. So I didn't just have one servo though, I had 2. So we're going to do servo again, and then servo B. Cool. That is the servos done for now. We have created the servo objects that we will use. Now we need to declare pin numbers for our joystick. So I'm going to use the keyword const, and these are going to be numbers. So I'm going to cast them as integers, and I'm going to say that X is assigned A0. This A0 is the pin on the board that it is assigned to. And we're going to use a comma. Y is A1. And if we plugged them in backwards, we can always switch them in the code, or we can just switch them on the actual breadboard. All right, then we're going to cap it off with a semicolon. All right, I'm going to make my code a little bit more readable here. I like to separate my code out into little bits. Let's get rid of this comment. We know that the setup is where you put your setup. So the first thing I'm going to do is I'm going to say where I attach my servos at. And I'm going to use the keyword servo and then the method attach. So I'm looking at my breadboard right now and I attach them at 3 and 4. So this is the part where you decide which one is servo A and which one is servo B. So in the void setup, I'm going to use a lowercase servo dot attach. And you can see how the syntactical highlighting highlights this, lets me know that I'm using a method now. I'm going to say that it is at, oh, let me look at my thing again, because I forgot already. Okay, I'm going to say that servo is attached to 2. And I forgot something here. Servo A is attached to 2. That's literally saying, hey, servo A is attached to pin 2. Which means servo B is attached to pin 3. And we close it with a semicolon. Okay. So let's go up here. Let's add a comment. We'll say assigns servos to pin on Arduino. Cool. Let's go down here, press enter a few times. Now we need to set the modes of our pins for our joystick. So let's go throw a comment. Set modes of pins for joystick. There are 3 technically usable pins on the joystick, but we only use 2, so we're going to only use 2. Now to declare a pin or set the mode of it, we use the keyword pin mode. PIN, then camel case MODE, pin mode, open in parentheses. The first thing that comes is the name that you want to assign the pin, and then what type of input or output that it is. So I want to do my X first, and it's going to be input. And remember, X is assigned to my analog 0, so now whatever value comes in through A0 is assigned to the variable X, and the Arduino knows that it's an input. Let's do the same thing for the Y. So I'm going to say pin mode, Y, input as well. Cool. So now if I want to have my terminal read something so I can tell if it's working or not, which is also a great way of debugging, I need to establish a serial connection. Serial is just the blue cable that comes with your Arduino. All it is the sending and transferring of data. So I'm going to use the keyword serial dot begin, and we're going to begin at a 9600 baud rate. We don't need to worry about what that is right now. Just know that it's the most basic form of communication between an Arduino and a computer. Some have higher baud rates, some have lower. Okay, cool. That is the entire setup. Look at that. Let's go ahead and be consistent, throw in a comment. Establish serial link. So far, we have imported a library. Well, we've installed a library, imported a library, created 2 servos, cast our pins to certain variables, and then we have attached our servos in such a way, and we have established the input mode of our pins X and Y, which are assigned to pins A0 and A1, and we've also began a serial link. So that is the completion of our setup. Now, let's go ahead and go to our loop. Now, in the loop, we're going to write some code that will read the analog position of our joystick and transfer that to the servo. So let's do the X first. So we're going to say in a comment, we're going to move servo A if the joystick moves in X direction. Now we're not going to use a condition for this. We're just going to hard code it. So we're going to say serial print, and we want to see if something is happening. So in case we move our joystick and the servos don't move, this serial print will let us know that our joystick is moving by casting a number to the serial output. Sometimes people call it the terminal. I don't think it's a terminal. I think down here is a terminal, but it's whatever. So how do we get the X value? Well, we're going to use a function or method, whatever you want to call it, called analog read. But first, let's go ahead and print that value to the console, the terminal, the output, that thing. So we're going to say serial dot print again, and this time we're going to call the analog pin. So we're going to read what's on that pin. So analog read, and it's camel cased, and we're going to say for the X direction, we're going to do X over 6. Let's put our X in parentheses just to be a little extra safe. And then we'll close that off with a semicolon. And now that we're reading it, let's go ahead and write it or send it to our servo. So whenever we read something, that's an input. Whenever we write something, that's an output. So let's send this to servo A. So we'll call on it. We'll say servo A dot write or send output, open parentheses, And we're going to say analog read. So we're going to read what we get from the analog stick. And we'll just say X, oh, wrong X, X over 6. And we'll close that with a semicolon. So this is going to, first of all, print whatever value this is to our serial monitor. And then we're going to write that value to our servo. Let's fix that right there. There we go. And now we're going to do the same thing for our Y value. So we're going to add in a comment. Oh my goodness. Move servo B if joystick moves in Y direction. Look at that. So once again, we're going to do serial print, but you know what? Let's go ahead and just select all this. We're going to press Control C or Command C if you're on Mac like I am, and then Control V or Command V. Because why not? Code is modular for a reason. Let's go ahead and change this. We're going to change that guy to Y, and we'll change this guy to Y as well as this one. And now I'm going to upload my code, and I will see you back in the real world. Sure, crappy here. So the keen-eyed amongst you may have noticed a problem in the code, and that problem is right here. So up on line 23, I have x over 6, and then on line 24, x over 6. So what we're doing is we're reading analog x, and we're returning the quotient of that average divided by 6. Here on line 28, however, I'm returning the entire thing of y over 6. So that is not doing anything. So what we need to do here to fix this is just get rid of these extra parentheses and leave it like this. There we go. That's the fix. All right, enjoy the video.
So now if we go back to our example, we will see that right here there are 2 servos, and here's a joystick. So if we move in the Y direction, one servo moves. If we move in the X direction, the other servo moves. How fun is that? Now I'm sure there's some practical applications for it, but I have a stupid one in mind. A useless one, as some people let me know. Let's see what it is.